everyone. Today I'm going to talk about periodic table. Okay? So Mendeleev's periodic table. Mendeleev is the people who invented the periodic table. Okay? So in 1869, Mendeleev published a periodic table, but he arranged by atomic mass, so it's not a periodic table we see now. Okay? So he put the elements with the same properties as the same groups. So first, but there's some problems. So like this, you can see this. So the right side should be have greater atomic mass than the left side. But he arranged the iodine and tellurium in the right side, but the tellurium have greater the atomic mass than the iodine. But he's still arranging like that because he thinks the iodine has similar properties to the chlorine, Br, and the At, and the Te has similar property to silicons, Se, or other elements in the same groups. Okay? So at that time, not all element is founded. So only some of them is founded. So he believed, so at the Higgs periodic table, there's some empty space that he thinks there's an element will be fit into the space, but they haven't found it. And they can predict the atomic mass. For example, he can predict there's an element have 68 and 70 would be discovered maybe in the future. So remember the 101, Taipei 101 play fireworks, okay? So Taipei 101 is MD, so you can see the Mendeleev is M and D. So the whole name for MD is Mendeleevian. Mendeleevian is to honor Mendeleev, but it's not spelled correct. So the Mendeleevian is not this word, but it's just says it's called Mendeleevian. So remember, Mendeleev is not Mendeleevian. Mendeleev is people. Most of our people is made of carbon instead of Mendeleevian, the element. And it may be radioactive. Mostly. Who's mostly? Mostly looks like this stupid. Okay? So who is mostly? So in 1913, mostly shoot X-rays through different crystals of elements and study the wavelength of radiation. First, who is mostly? Mostly worked with Lucifer. Who is Lucifer? Lucifer invented the protons. So protons is the atomic number. So he worked with the people who invent protons, so he knows the atomic number. Since he knows the atomic number, he shoots X-rays through different crystals and study the wavelength of the radiation. We found the relationship between the wavelength and the atomic number is a close relationship between them because he thinks that the periodic table should arrange in atomic number rather than atomic mass. And then Mendeleev is angry, but Mendeleev is already died. Then when the mostly is so remember, wait a second. Remember, so who mostly died in a very young age because he go to a world war and he is being shot and then he died. Okay, so that's because Mendeleev is a ghost and he just pushing out of the war and then he boom and he's being shot. So because Mendeleev think he's bad because Mendeleev invented the periodic table and then he invented a better one. So Mendeleev killed him. Okay? So what is periodic law? Periodic law is a law. Of course, periodic law is a law, of course. So what is periodic law? Periodic law is the element arranged in how element arranged in a where is it? Wait a second. Okay, in the periodic table. For example, Like the elements in the same group have similar properties but not the same properties. So they have the same valence electrons, and elements in the same period have the same valence shell. The first one, when you see at periodic table, most of it is metals. What is metals? Metal is a good conductor. So it conducts electricity and heat. Because that it tends to give off electrons. While the temperature is rising, the conductivity is decreased. And it's shining like this one. And it's ductile or ductile like this one. It can stretch very long. And it's malleable like me. It can become very, very thin, flat. And it can expand and then contract like the coil, and have high melting point except for mercury, which is liquid in room temperature. All of it is solid. Properties of metals. Properties of metals. So an oxide metal put into water, or for the hydroxide things, which are basic. For example, oxide calcium put into the water becomes hydroxide calcium, which is a basic. And a hydride metal put into water is also a hydroxide thing, but you also get some hydrogen. For example, the hydride sodium put into water becomes hydroxide sodium, and you also get some gas, the hydrogen gas. The melting point of alkaline metal decreases when the atomic number increases. Okay, properties of nonmetals. Properties of nonmetals. Okay, so most elements is comprised in human body are nonmetals. For example, you can see the carbon. Most of people are made of carbon, except for robots. Okay, so because they gain electrons instead of giving, they can conduct electricity instead of black lead. Okay, so they have low melting point. Some are even gases. So now it's very strange. An oxide nonmetal put into water is form hydroxide things. Well, when in water will form hydroxide. Well, it's acid. So if you put the oxide nonmetal you put into water, and then it's very sour. Okay, you can say sour, but actually it's acid. Okay, so for example, the CO2, which is carbon dioxide put into water, is 4 sodas. So soda is this, but soda have a lot of sugars. Okay, so a hydride nonmetal put into water can form basic acid or neutral. For example, HF put into water is acid, and H2O is neutral. H2O put into water, and water is neutral. And HNO3 put into water is basic. So that means something is wrong. What thing is wrong? So water is a hydride things and a oxide things. So instead, oxide water is form acid, but not always. Sometimes it becomes neutral. For example, an oxide hydrogen put into water is neutral. So this is a little bit wrong. What is a metallic character? Okay, so metallic character is a level of reactivity of a metal. So how easy to lose electron? The more easy to lose electron, the higher the metallic character is. So first, it increases from the top to the bottom, and it increase from the right to the left. So why? First, why it increases from the top to the bottom. So first, let's think. If there's more proton, there's more energy in attracting the electrons. But remember, when it comes down, there's more shells. More shells, that means more distance. So it's very confusing. So for example, let's see this formula. Fe is equal to R squared over R squared over Q times Q1 Q2. So this is just so the Q is the electric charge, like the proton and electrons. R is the distance. For example, those two distant. So how to do it? It's very, very easy. Yes. So for example, we can see the electric charge of all electrons is always same. So what always affected is only the Q1. So the Q1 affected and the R squared affected. R squared. So Q1 is just like 5 or 6 or just a number, but the R squared is maybe like 8 times 8 maybe become 64. It's bigger than just 5 or 6. Because R is squared, that means they make more effect to the attracting than the Q. Okay. Delete it. Yay! Okay. And then to the next page. So, what about non-metallic character? Non-metallic character is just the opposite of metallic character. So it's in different, just opposite direction. Because that non-metallic character is just to take electrons instead of giving electrons. So for example, if you are very easy to give up electrons, you are very hard to get electrons. So it's just in opposite direction. What is metalloid? Metalloid is either metal nor non-metals. It's just metals. No, it's just non-metals. It's metalloids. Okay. So there's 6 metalloids. So some people say same, so it's very easy. Wait a second. It's very easy. So now it says same. What? Just a yellow one. 1, 2, 3, 4, 5, 6, 7. So why? So actually you can see green pigment means that you have to make in lab, and this is green. So that means you can't find it in nature. So some people say there's only 6. What is the 6th metalloid? All of them are solid in room temperature. First one have 3 valence electrons, boron, and tend to act like metals by giving off electrons. More than 4 valence electrons, like As or the At or the tellurium, tend to act like nonmetals by gaining electrons. Exactly 4 electrons like silicons and Ge, either metals nor non-metals, so you can think it's metals or you can think it's non-metals. It's just in a between. Oh, I forgot to do something. Okay. So exactly 4 electrons, valence electrons, can make semiconductors. Semiconductors. What is semiconductors? Semiconductors is sometimes they can conduct electricity, sometimes they can't. So like silicon can use to make chips, computer chips. Noble gas and octet rules. So you can see on the periodic table. Which one is noble gas? So in this one. So because that helium is 1, 2, is only have 2 valence electrons. Okay. So all noble gases octet rules. Some people say that actually is wrong, because helium is only have 2 So it's not. So except for helium, all noble gas are octet rules. That means they have 8 valence electrons. This is right. Octet rule. The octet rule. Okay, so the octet rule says that the compound so have 8 valence electrons. So you can see all the atoms right here tend to have valence electrons that are octet rule. So the compound combine with other elements to form a compound, then they can get the octet rules. So now they are stable. So that's why some like the noble gas tends to not just compound with just combine with other elements because they're already full valence electrons. So all of them are colorless. That means you can see it in you can see it like chlorine, like you can see green gas, but there's no color. It's just like the air. Okay. So different noble gas give different colors of light. So like you put into the light, okay, and then like a neon light, it's orange, red light, and like the XE got different light. So there's helium and other things. So actually, sometimes if you put this inside, then sometimes when you put the light right here, then the light just floats up because there's helium inside. Okay, so maybe it's not. Okay. So what is halogons? What is halogon? Halogon is not a stable thing. So halogon is very not stable because it always tends to take electrons. So they are highly reactive nonmetals. It has 7 valence electrons, so they always just take 1 to get 8. They have very low melting point and a low boiling point. And some of them are gases in room temperatures. So you can put it into a lamp and then you can create different colors of light. You can just create light. What is atomic radius? Atomic radius is the radius of atom, okay? So remember, wait a second. Okay? So for example, if something's nucleus is red, and the electrons may be blue, and just goes around it. Okay, so like that. And if this electron is just an electron cloud, will spin around it, like that. So because it's hard to measure when something is just moving around, so we measure it by taking 2 identical atoms and measure the distance from the 2 nucleus and divide it by 2 is just the atomic radius. But you need to use 2 identical atoms. Okay? Hey. What? What? Okay, so what is the unit? So we're gonna see like atomic radius. Wait a second. You can see like this. Okay, so you can see mostly it's used Angstrom, but sometimes it's used picometers too. It's got picometers, PM. It's got picometers. Okay. So sometimes they use picometers, but mostly they use angstroms or I. No! No! So this is a period, so you can see. Okay? So first one you can see in the same groups, increase from the top to the bottom. So why? Because more shells. So because more shells, so it's become bigger, of course. And another thing, so in the same period, it decreases from the left to the right. Why? Because, not considering shells, because remember the periodic law that elements in the same period have the same subshells. So, in the same shells, but it has more electrons. No, they have more protons inside, attracting them, so it becomes smaller and compressed. Wait a second. I think I'm not stupid. Okay. So this is just the same things. This is just a reactivity. What is reactivity? Reactivity of atom depends on partly how easy the electron can be removed from an atom or gain electrons. Okay, that's the reactivity. And what is ionization energy? So what is ionization energy? Ionization energy is energy to move the valence electrons away. So it increases from the left to the right because that there's more valence electrons. And it decreases from the top to the bottom because it's farther from the protons. So remember we said that the metallic character decrease from the top to the bottom because it takes less energy to take away electrons. It's easier to get away the valence electron. So the same as ionization energy. So it just decreases from the top to the bottoms. What is electron shell? Electron shell is to shell electrons. Yes, of course. So electron shell is to shell electron. So in different shells, the inner shell will show the outer shell. And when it's in the same shell, the s orbitals will show the p orbitals. So it's very strange. So for example, like you can see like this. So it just shows like this because the S will just make a round shape and the P may be a little oval or not oval shape. So it's a little like this picture showing. So the S shows the P. So aluminum has lower ionization energy than magnesium. So first, let's see one thing. So it increases what? From the left to the right. It increases from the left to the right. Now ionization energy, aluminum aluminum has lower ionization energy than magnesium. So aluminum is right here and magnesium is right here. But aluminum has smaller than here, so it's not right. So it's very easy. It's very easy. So it's this picture. So it's just one to the sand. So the only difference is this one. So remember this 3s, but it has the extra p. So S will show this p. So aluminum is easier. It's harder to take away electrons. Yes. So aluminum. So because S will show the p. So group 15 and group 16. So what happened? So first, let's see, helium, hydrogen, 2, 3, 4, 5, 6. So we can see maybe it's right, maybe here. Okay. So why something drops? So 3, 4, 5, 6, 7. Okay. So why it suddenly drops? So it's very easy. So because first is this picture. So first we can see is here. Now this is just like that, but when it comes to oxygen, a more electron is adding into the nitrogen. So you see, so no one wants to share the orbitals with like more extra electrons. So all the free electron will repel it. So it's easy to take away the electrons. So that's why it suddenly drops. Okay, so what is electron affinity? So when you give a neutral atom some electrons, it releases some energy, so it's very hard to measure it, actually. Okay, so it's very hard to measure because that sometimes a negative number because you release, but sometimes you gave its energy too, so it becomes a positive number. So electron affinity is measured in gas state. It's always measured in gas state, so that's why some metals is very hard to measure because there's some you need to give a high temperature to turn into gas. Okay, so it's become more negative when you move from the left to the right, from the bottom to the top. Okay, so what is ionic radio? Ionic radio is just the radius of ions. So for example, the gray part is just the original atoms. So this one tends to give off electrons, so it becomes smaller. It's the green, and this one tends to take electrons, so it becomes bigger. So it's just when you take electron, you become bigger. When you release electron, it becomes smaller. Just like that. It's very easy. Okay, so now, so it's basic neutral atom. So this one is Ca. So actually, what is Ca? So Ca actually CaO is dissolving. So CaO dissolving in water because Ca is a metal, so it is basic, and this is so basic. This is acid. This is acid. This is acid. This is neutral. This is basic. Bye bye.